Okay, this video is an introduction to refraction, not reflection. Refraction, the bending of light. Previously, we talked about it bouncing off a surface. Now we're going to talk about it being bent as it travels through one medium going into another one. Little focus issue there. Okay, it's settling down. Okay, so let's look at some refraction basics. The main thing that we're going to talk about, well, let's explain what it is. Refraction. Light rays bend upon entering a new medium. For example, we could have air, which is a lot like a vacuum, which has an index of essentially 1, going into plastic. And I haven't drawn the ray. We're going to ignore the reflection. It's there. I'll show it to you, but we're going to kind of ignore the reflection for this part. We know theta incident equals theta reflected, but we're going to ignore that. What I'm claiming is the light will actually bend. And in this case, as you go from a low index to a high index, light bends towards the normal. Maybe you can see why we like to use normals in optics now, right? There's one normal here, and so the light will bend towards this. I'm exaggerating this a little bit because I don't know the exact index of the plastic we're going to use. That's going to be the example in a video later on, and we'll be able to calculate the index of material based on these. So this would be theta 1, and this we would call theta 2. So in this case, Snell's law says that N1, the index of refraction of the first medium, times sine theta 1, the angle to the normal of the surface on the one medium side, is equal to N2 sine theta 2. I think the picture is easier to understand. N1, the medium here with that angle to the normal, and N2, the new medium, and theta 2. The angle to the normal in the new medium. So that's Snell's law. So if you go from high to low index, going the opposite way, something different happens. And actually, in this case, light should bend away from the normal. And then something kind of special can occur as well. If the angles are large enough, for large angles, you get total internal reflection. No refraction occurs. Well, I'll show you this with an example in just a second. So the classic example is going from low to high index, like air into glass or air into water or maybe water into glass. The light will bend towards the normal, and that always occurs. What happens is if you try to go the other way, right, if your input angle is too large, you could imagine it's not able to refract out, and in those situations, total internal reflection occurs. I'm just going to call that TIR for short. Let me get to the demo and show you this, and then we can do some numbers in a minute in another video. Come on now. Let me hit the lights so you can see it better. Okay. Hopefully you can see things a little bit here. Now, again, I want to point out there is a reflection here. You can see it, but it's very faint because this isn't a mirror. I think only somewhere around 4 to 8% of the light is probably reflecting off that front surface. Kind of like glare. If you've ever looked at a window, you've seen glare, that's a reflection. But it's negligible compared to the most of the beam, which gets transmitted. And what we could see here is the input angle is going to be, well, we could do the math on this, and we will in a minute. But I just want to point out that the angle in here must relate to either 30 or 60, but the output angle looks like it's closer to 10 degrees, something like that. So it does, it looks like the input is 30 and the output is 10. So we see that there's a different angle. Now, why is there no bending at this surface? Here, the normal is this line right here, right? So there's an angle to the normal here. Whereas on this side, right, there's no angle to the normal because I've got this centered just right. So it comes radially out. And so that's why this is a nice device. This is a semicircular lens. That's going to be a problem that we work on in a minute. So this is when we're going from a low index to a high index. Now we can actually flip this to show what happens the other way. Give me a second. Okay, so now the light comes straight in, radially in. And now what happens if I rotate this thing? We can start to see refraction. All right, I'm trying to keep it centered the best I can. And what happens is, as you go to larger and larger angles, we can see a stronger and stronger reflection here. Whoops, kind of screwing this up. And right about here, when this angle gets to 90 degrees, look at this subtle thing. So we're getting to a larger and larger index. Larger and larger incident angle. The normal's about right there, right? I can't see because I'm upside down and backwards. But as we go, watch this ray right here. When the output angle reaches 90, flat parallel to the surface, you no longer see any light being refracted out the other side. And notice this beam suddenly gets bright. All of it is reflected instead of any refraction. This is the special angle at which total internal reflection first occurs, when the output angle equals 90. Let's go back to the board and write some stuff down. Turning on the lights, give me just a second. Whoops. There we go. So notice the following. I'm going to try and analyze this TIR a little bit, and then we can do problems later. So there's a critical angle. We saw if you have N, the high index is the first side. On the output side, the low index, we saw when you get 90 degrees, for any angle past this special angle, total internal reflection occurs. So notice you can actually get, if you want to pause the video and rearrange this, that's great. I'm just going to crank this out. I know that sine of 90 degrees is 1. So rearranging this, that's going to be sine inverse of, what is it, N low over N high. That tells you the critical angle for total internal reflection. And so we saw in the last videos how to handle reflection problems. Those are going to be useful if we have issues where we have total internal reflection occurring. So we need to understand both reflection and refraction to do refraction problems in some cases. All right, and so we're going to do some numerical examples in a minute. This was just to get you used to the terms. Snell's law, low index, high index, different mediums, angles measured to the norm, total internal reflection.